or factor? What'd you get for your factors? X plus 1 and x plus 4. Denominator, what'd you get for your factoring there? There's a GCF of 4 and then x plus 3. All right, so what did you come up with for holes? None. Vertical asymptotes. X equals -3. X-intercepts. -1, -4. Y-intercepts. 1/3. And horizontal asymptote. What was it? None? None. All right. Check your work. See how it went. Any of those that you have questions about, we've talked about this a ton, right? If you do have a question, though, if you're like, Ms. Berg, why is it none? Why is it 1/3? I have a different number. Now is the time. All right, we're going to go ahead and plot what we have here and see if we can draw this graph. You ready? All right. Holes, there are none, but that's okay because normally we put those on at the end anyways, right? All right. Vertical asymptote at -3. So draw that in there. X-intercept, -1. And then there's another one at -4. Y-intercept at 1/3. So right there, approximately, right? And then no horizontal asymptotes. So what does that mean if there's no horizontal asymptotes? What's going to happen at the ends of the graph? They're either going up or they're going down, right? They're not going to turn and go sideways. They're not going to run horizontally. They're either going up or going down, okay? All right, so this is the information that we have, and we're going to draw this graph, all right? All right. Before we start, one thing, they are scheduling today, so if you are a freshman only, you're going to schedule out of this class, all right? So if you're a freshman, grab your scheduling sheet, and when they're ready for you, she'll start calling you out, and we'll just kind of rotate, okay? So just be one person at a time. Huh? Freshman? Oh, well, you get to go first today.
Oh, wait. Is that an ad?
Huh?
Yes. Alphabet.
Math. No, you don't have to go like first. Like you just anybody can go first, but like you get to go in the morning. Okay, sophomores, you should have a time to schedule later today, so they're not worried about you. All right, are we ready to graph this? Yes. Okay. So we need to decide what is happening here. There's going to be two sections of this graph because there's a vertical asymptote. So you're going to have one section over here, and you're going to have one section over here, okay? All right, what do we know so far? Anybody know any directions that this graph is headed in any capacity?
It'll come from the left and either go up or down through that left x-intercept.
This one?
Yes.
It'll come this direction and either go like this. Don't draw this. Either like that, or it could go like that. Yes. So that's pretty much your only two options. But we don't know which one, do we? Anybody have any inkling as to which one it is? Like you have a reason as to why you're going to pick? Starts at the top and goes down, or starts at the bottom and goes up? Shannon, what you think?
I would say it starts at the bottom. Goes up
So you have a vote for this one right here, starting at the bottom, going up?
Yeah, because the one on the other side has to start at the top.
You should never compare it to the one on the other side. All right, that is going to get you in some hot waters pretty quickly as these get more complicated, okay? So what is happening over here is not impacting what's happening over here, all right? Yes. But that is a thought to maybe try to compare to the other side, and so I'm here to tell you that you don't want to base it off of the other side of your graph. Because sometimes it goes up, sometimes it goes down, sometimes it goes the same direction, sometimes it goes opposite directions. We really don't know for sure. Anybody else have any ideas? Up or down, up or down? No? No? Okay. You're right. There's really no way to tell right now, is there? There's not. It could be this one where it goes up. It could be this one where it goes down. We're just not sure. And so what we have to do is we're going to do a little bit more work to decide which one is which. A little bit more work, all right?
What's a little bit?
A little bit more work. You're going to see right now. All right, so what we're going to do is we are going to pick one of the x values over here, any of the x values over here, and we're going to decide, is that y value a positive number, in which case it would be up here, or is it a negative number, in which case it would be down here? Does that make sense? Kind of what we're doing? We're going to pick one of the x values, decide if its y value is positive, which would make it this graph, or if its y value is negative, it would make it that graph. All right, so here's how we do this. Somebody pick a number over here. X value over here.
-2.
-5. -2 is right here, so -2 wouldn't work, would it?
-5.
-5 is right here, so -5 would in fact work. So what we're going to do is we are going to plug in -5, and we want to find the y value, if it's positive versus if it's negative. All right. I don't actually care what the y value is, okay? I don't care what number it is. What I want to know is it's positive or negative. Does that make sense? If it's positive, then I know it has to be up here going down. If it's negative, I know the graph has to look like this. I don't care exactly where that number falls. Like, that's not that important when we're sketching this graph, right? And so what we're going to do is we're going to test some values. We're going to test -5, and we're going to plug it in to either of our two equations to decide if we get a positive or negative. It's easiest to plug it into the factored form equation. I'm just going to be honest. So if you plug in -5 in here, -5 plus 1 is -4. It's negative, and that's what we really care about, okay, is the fact that it's negative. So you can put -4 if you want, or you can just say, hey, that first factor will be a negative. When you put -5 in here, what do you get? -5 plus 4 is -1, which is also a negative number. So on the top, you have a negative times a negative. And what is a negative times a negative? It's positive. So on the top of that fraction, you're going to have a positive number. We don't care what the actual value is. We just care that it is a positive. On the bottom of the fraction, you have 4. And 4 is a positive, and plugging in numbers isn't going to change that 4, right? That's just a 4 in the front. So I'm going to say there's a positive there for the 4. And then if you plug -5 in here, -5 plus 2 or plus 3 is -2, and so that would be a negative number. And those are still being multiplied because it's factored form multiplication. And so a positive times a negative is a negative. And then you can go ahead and do the division. Positive divided by negative is negative. So when you plug in -5, you get a negative number, which means over here on our graph, at -5, it's a negative number. So it has to be that section of the graph right there. So we know it's not this one. It has to be that one.
Is it bottom or like the bottom?
No. What I'm looking for is that it goes this direction and that it goes up. And that you go through your x-intercept. If you draw it like this, I'm cool with that. If you draw it like this, I'm okay with that. If you draw it like this, not so okay with that because that looks like a horizontal asymptote, right? So as long as you have something that does not represent a horizontal asymptote, I'm okay. So Shannon, you were right. It was that bottom one. I mean, you did have a 50-50 shot, right? All right. So a little bit harder because we don't necessarily have enough information here to know exactly where the graph is going to go, but we now have this extra thing that we can do of testing values to decide if it's positive or negative, and it'll tell us where our graph needs to end up. All right, on this side, what's happening over here? Will you sit at my desk, please? What was that? It has to go through these 2 points, yes? It has to connect them. There. All right. From here, do we know where it goes from the y-intercept? Do we know where it goes?
Oh, it couldn't go down. I think this would be another x-intercept.
Right. It can't go this way because it would cross the x-axis. And you're not allowed to cross unless there's actually an x-intercept there, right? So that means it can't go down. It has to go up. So that is the legit reason why you know the graph has to go the way it goes, is it can't cross the x-axis again, all right? Michelle, this is the next page in the packet that I gave you. All right, from this point, do we know which way it goes? Up or down? Up, down, up, down, up, down. Down, up. Who votes up?
Oh, wait. Never mind.
Anybody vote up?
No, never mind.
Go down? Why do y'all think down? What's your legit reason as to why it goes down? I want to hear this. Because you what? Why does it have to go down? Yeah. Because of the asymptote? It wouldn't curve right, it would just bounce off there. That would be a weird curve. It would come down, hit this one, bounce up.
There's no reason we just think it looks better.
What was that?
There's no reason we just think it looks better.
There's no reason. You just think it looks better. In your mind, it looks like it should go down because this whole graph is going down. Is that a legit reason to say that it has to go down? No.
Our reason, though.
It's your reason.
That's how our minds are working right now.
It's your reason, but it's not guaranteeing that it goes
Do we have to
down.
do that thing again?
So we're going to have to test another value to decide if it's positive or negative. Yes. So now you're in this section of your graph, right? Right in here. So you need a number in this space.
Now you can do
Negative 2.
Now you can do negative 2, yes. You can't do 0 because 0 is right here. So you have to do something between negative 1 and negative 3. So negative 2 is perfect. So we're going to roll negative 2 now. All right, when you plug in negative 2, it's much easier to figure out positive, negatives, in factors form, right? Negative 2 plus 1 is a negative. And we don't care what number, we just care that it is a negative. Negative 2 plus 4, that's a positive. So on the top, negative times positive is negative. On the bottom, you still have the 4, and the 4 is going to stay positive the whole time, right? So there is a positive there for the 4. And then in here, negative 2 plus 3, 1, which is, so positive times positive is positive on the bottom, and a negative divided by a positive number will be negative. So guess what? You all were right. It does go down. But the reason is not because it looks like it should. All right?
It's still true.
Yeah, no. It looks like it should.
It does.
I could change this equation slightly to make it go up. Does that make sense? I could go in there and I could be like, bam, I can do this and it will go up instead. And then that way it would all fall apart.
But you can also not.
I could also not. I could also do something else in there to like make it look weird, right? I could do a lot of things. And so unless you know all the nitty gritty of how all those pieces work together, you really just have to test some values. And I will tell you something. This is not the only time you will do this. Okay? It's not I'm going to teach you how to do it for rational graphs and then that's it and you'll never see it again. You will see it in pre-cal. You will see it in dual credit. You will see it in calculus if you take calculus. Okay? You will see it often in those classes.
Have you seen that post of the guy? Like, there's like this drawn game, and it changes the equation in his arms move based on how the graph is out.
No, I haven't seen that. Show me after class today. I'll be interested. All right, number 2. We're just gonna keep practicing. You are good, hopefully, yes, to find the holes, vertical asymptotes, x-intercepts, y-intercept, horizontal asymptote. You find those 5 things. All right, how did the numerator factor? There was an x that they had in common. X minus 4. Denominator? There was a 4 in common. And then leftover was an x squared minus 9, which you guys need to recognize as a difference of squares, right? And so, yeah, if you take out the 4 and you're like x squared and then you write minus and you're like 9, you can just erase it and then just go x plus 3, x minus 3, right? Yeah, so recognize those difference of squares makes life easier. All right, holes. None, no holes? Vertical asymptotes. -3, +3. Okay, x-intercepts. 0 and +4. Y-intercept. 0. By the way, if there's an x-intercept at 0, there should be a y-intercept at 0. And horizontal asymptote. 1/4. All right, check your work with these. Do you agree with them all? Do you disagree? Are there any that you're questioning? Where did that come from? Now is your chance to ask before we get into this graph. The poor 1/4, is that what you're talking about? 1/4? Yeah.
I don't think that's what it is.
Yeah.
Because I was looking at it like, I can't show this about it.
Yeah, when those horizontal asymptotes are fractions like that, they definitely make it look really complicated. So vertical asymptote at 3, yes. Another vertical asymptote at -3. No holes, so we don't have to worry about those later. X-intercepts, one here at 0. The other one is at 4, so 1, 2, 3, 4, right there. And y-intercept at 0, that's already on there, yes. And then horizontal asymptote at 1/4. And you just make it look close, right? Mine's more at like a half, and that's okay. As long as you're somewhere between 0 and 1, just try to get close, all right? Huh?
Don't go all the way up to 2.
Yeah, don't go up to 2.
Or to 1.
Or to 1, yes. Don't go to 1 either. 1/4 is different than 1, right? Somewhere between the 0 and 1, probably closer to the 0 is where we'd be looking at. All right. How many sections of graph are we going to have for this one? No, not 6. Not 6 pieces of graph. You're going to have 3. One here. It's either in the top or the bottom. One here, right? And one here. Yes?
We were looking at it like.
Yeah, so that's the thing. It's not 6 pieces of graph. It's only 3, right? 3 pieces of graph. So if there's one up here, then there's not one down here. If there's one up here, it's not down here, and vice versa, right? All right, this is the first one that we are going to see that has 3 pieces, yes? All right, so 2 of the pieces are pretty easy to make, and those are the 2 that are on the outsides. So this piece is going to be pretty easy to make, and this piece will be easy to make as well. Much easier than the middle. Would you like to do the left or the right first? The right, because you have the extra point. So you know you have this point, so the graph has to go along the horizontal asymptote, right? And then here, what's it going to do? It's going to go down along that vertical asymptote there. All right, what's going to happen over here?
There's going to be a line.
Huh? There's going to be, well, it's not so much a line, but a curve, right? There's going to be a piece of graph somewhere. It's either in the top or the bottom. It's in the top. How do we know it's in the top? Besides, it looks like it can't cross the x-axis, right? That is a legit reason as to why you know where the graph should go, is it can't cross the x-axis again. So that means it's going to be curving like this, right? Running along the horizontal asymptote this way and along your vertical asymptote that way. All right, in the middle. And this is something that you haven't really seen all that much. Most people would think that it goes like this, right? Yes? Is that kind of what you would be led to believe? All right. And the reason you think it goes like this is because the horizontal asymptote, right? So the rule is that you can't cross a vertical, that's not allowed, but you can actually cross a horizontal. You are allowed to cross a horizontal asymptote. And when you cross it, it will most likely be in the middle because horizontal asymptotes is what's happening at the ends of your graph. It's where the graph is going at the ends. It doesn't tell you anything about the middle. Absolutely nothing about the middle, unfortunately. But it is going to tell you this end piece here, and it will tell you this end piece here, but it does not have any impact. So it's almost like you could erase it here in the middle. It's free game in the middle. You can literally go anywhere in the middle as long as you stay between your two horizontal or your two vertical asymptotes, okay? So I erased it up here so it doesn't get in our way because it really doesn't have any impact on the middle of this graph. All right. So we have 1 point in the middle. Where does it go? Does it go down on both sides? Maybe it goes up on both sides. Maybe one goes up and one goes down. Huh? You know how to what?
I know where this is from.
Oh, you know where this is from? Ah. What did that remind you of when I said both up, both down, one on each side? The degree and the leading coefficient, right? And the end behavior of a polynomial. Because this is a polynomial over a polynomial, so it would have some same features of a polynomial, right? Yeah, so that's essentially what we're doing. Which way is it going? Unfortunately, though, nothing in the equation is going to tell us which way. So we should test some values. So what we're going to do is we don't know which way. Both up, both down, one on each side. We don't know, so we're going to do value testing, all right? We're going to test one on this side, and then we'll have to test one on that side. So give me a number over here. 2. So testing x equals 2. All right, when you put in 2 into just an x, it's going to be 2, right? Positive or negative? Just into the x. It will be a positive, right? Just into the x. Plugging it into x minus 4, this would be 2 minus 4, and 2 minus 4 is? Negative. So the top is negative. On the bottom, you have a 4 in the front. That 4 will always be a positive, right? So I'm going to put positive for that 4. Putting in 2 here, 2 plus 3 is 5, which is positive. And 2 minus 3 is negative 1, so that is a negative. Positive times negative is a negative. Perfect. It's negative. And a negative divided by a negative at the end will make this positive. So at 2, that means it's positive. So from here, the graph has to go up. It goes up. All right, from here on this side, it either goes up or it goes down. Do we have anything that's going to tell us up or down? You can try negative 2. Negative 2 would tell you up or down. You could also try negative 1. You could try negative 2.5. You could try negative 1.5, as long as it's a number between 0 and negative 3. Are you guys going with negative 2 then?
Yes.
All right. I'm going to let you try it. See if it's positive or negative. You decide. Give it a shot. See what you come up with. And then I'll tell you. We'll make sure you got the right one. So check positive, negative. All right, on the top you would have had a negative times a negative, so a positive on the top, yes? Yes? That was a little tricky on that first negative, because if you plug in -2 for that x, you're just going to have -2, and it is a negative, right? On the bottom, it's going to be a positive times a negative, which is negative, for a grand total of negative, which means that it goes down. So the first instinct, this is the first instinct that Braden had, was it went down on this side and it went down on that side. And technically he wasn't right, was he?
He was half right.
He was half right, yes. Half right. Or half wrong. Glass half full, half empty, right?
Half right.
Yeah, so if you're not sure and you don't have a legit reason as to why it should go a certain direction, you should test a number, all right? To test a number. So a little bit new, right? Kind of a little extra piece there. How do you feel about it? Could be better? Could be better. All right, I'm going to give you the head start on number 3. See if you can find holes, vertical asymptotes, x-intercepts, y-intercepts, and horizontal asymptotes. Do you feel like the factoring and finding these 5 things is getting easier now that you've done it a ton? A little bit? You're starting to recognize some of the patterns in the factoring more, like easier? I wish I had like a random counter of like how many times I've factored in my life. Like how many different problems I've factored, you know? Be interesting.
I guess the question is, are you doing different problems, or are you doing it because you don't have a paper out there with you, so you're having to do all of these?
True. So maybe it's every time I've factored something. So like today would be, there'd be 2 and 2. So then this would be the 5th and 6th factoring problems essentially.
Those are just the ones you did with us. I'm sure you did some before you came in. You probably went over them too. You had just so
Oh, I know how to do these. I'm good. Yeah. They well, I've done these ones already because A group yesterday, we've done them. So I already know what the graphs look like because I already did them with my first and 5th block yesterday.
Because A group kind of did off as well as be the first Wednesday.
Yeah. So the day when you guys just worked on that practice review, that was the day that they caught up on. Don't worry, it gets complicated sometimes you guys are a day ahead of them, sometimes they're the day ahead of you, and it's weird. All right, so I know the numerator has a GCF of an x, right? Yes, and then left over, what are the factors? X plus 2, x minus 1. Denominator has a GCF of -4x, and then x plus 3. Just make sure, I think on your quiz, a couple of you had the wrong sign here. I'm going to give those back, by the way, at the end of class, so if you were wondering, they're coming back. All right, holes. 0. 0. By the way, if you messed up on the quiz with a hole, it was because you missed the fact that they both had an X in the top and an X in the bottom. And you said none, as opposed to saying that there was a hole there. So this one we're going to have to remember to put in a hole. Vertical asymptote. -3. That's actually been a vertical asymptote for all of our problems so far, hasn't it? Yeah. That's just a coincidence, by the way. But x-intercepts. 1 and -2. Y-intercept. None. None. That's because the top is 0 and the bottom is 0. So when the bottom is 0, that's when it's a none, right? Horizontal asymptote. Also none. By the way, when you don't have things, it makes the graphing harder, doesn't it? When things are missing, that's when the graphing gets harder. So any nones are going to be like, whew, I got less direction to go with. All right, hole that goes at the end. Vertical asymptote at -3. So put that on there. X-intercepts -2. +1. No y-intercept to go off of. Why is there no y-intercept? Because at 0, there's actually a hole, right? So wherever this graph crosses, we're actually going to put in a hole, wherever it crosses at. And no horizontal asymptote. So at the ends, it's not flattening out. It's either going up or going down. And this is all we have to go off of, isn't it? That is all of our information. So guess what we're going to have to do? We're going to have to pick numbers, right? They're called test values. Test values. So we're going to pick test values to decide if it's positive or negative. Would you like to start on the left-hand side or the right-hand side? The right? All right. Let's start. Where do you want to start at? You want to start at this point and decide if it goes up or down? Sure. So from here, does it go up? Does it go down? We don't know. We have to pick a number, right? So I need any number over here. Any one you want. 2? 2. 8,000 would work as well. You may do 8,000, yes. Okay, you can test 8,000 and just tell if it's positive or negative. You'll get the same thing. All right, so testing 2. Plugging in here, we'll have a positive. 2 plus 2 is positive. 2 minus 1 is positive. So the top is positive. -4, that's a times 2. Hey, everybody, look. -4 times 2, right? So that one's going to be a negative. So be careful there. That's a negative because that's a multiplication instead of add. And then 2 plus 3 is positive, which means the bottom is, which means the whole thing, which means that the graph goes down. And you can make it go like this. You can make it go really far down, as long as it's going down and it's not curving out, okay, to go horizontal. It can't go horizontal, it just goes down. All right, from here, from this point, we have to get to this point, right? This other x-intercept. So either this graph goes up like that, or it could go like that, couldn't it? Do we know whether it goes over the top into the positives or down below into the negatives? We don't know, do we? You think it goes down? All right. Anybody else think it goes down? Down,
It
up,
looks
down.
better going down.
Oh, it looks better going down.
So
But also,
So it might be going down. I don't know. How do we tell, though? How do we tell for sure? Pick a number, right? So between 1 and -2, pick a number. -1. Why did you not say 0?
-2.
0 is a hole. You don't want to pick 0. Don't pick -2 because that's right here, right? And what you get if you pick -2 is you'll get the whole thing is 0. Okay? So pick between and make sure you don't pick a hole if there's a hole between them. So we're going to pick -1. All right, you all test it. Decide if it's positive, so it goes above, or negative goes below. A y-intercept would have been super helpful there, because then we would have been able to tell, right? So you decide positive, negative, positive, negative. you have a verdict?
Yes.
Verdict? You think you know? Positive or negative? Does it go up into positives or down into negatives? Positives. I also you can't tell. That's my hair, by the way. I also got a positive. So I had negative, positive, negative on the top, positive, positive on the bottom, which leaves us with a positive. All right, so that means that I can erase this part, right? Because it has to go up, over. Sorry. Brendan, you were wrong. Bummer, huh?
I was right again. It goes down.
It does go down right here, right?
That's what I meant.
All right. I see what you're saying. This is decreasing. The whole thing doesn't go down, but at some point it goes down. Okay.
You go down.
By the way, I don't care if you make it go like this or just a little bit, right? As long as it's going across the top there into the positives, yes? All right. While we're doing this, it is creating a y-intercept right now, but what are we supposed to have there instead? A hole. If right now you want to put in the hole, you may put in the hole. Does that make sense? Whenever you have that piece of the graph drawn, you can put the hole in right away, or you can wait to the very end. So just erase wherever your graph was, put in a hole, and you are good to go. All right, last piece on this right-hand side is from -2. Either it's going down or it's going up.
If it goes up, it's gonna be ugly.
If it goes up, it's going to be ugly.
Better go down.
It better go down. You're like, what if it doesn't go down?
This problem is invalid. -2.5.
-2.5, is that a good test value to tell?
No, it's not a good test value.
Why not?
I don't like it.
Because it's a decimal.
Do you see where options are?
-2.
So you have to be between -2 and -3, and you can't use -2 or -3. It won't tell you positive or negative.
I don't like it.
Yeah, -2.5.
Alright, let's switch it to
All right.
Let's be real.
2.78934.
All right, guys, test this value for me. Test it. Just because it's a decimal really actually doesn't make it all that harder because I'm not asking for an actual number, right? I'm just asking for positive or negative. So really the decimal, yeah, we don't like them, but it really didn't make it crazy hard. Maybe a tad bit harder. Just a tad.
It's extreme.
So test -2.5.
This kind of looks like Morse code.
Like Morse code.
It does.
It's kind of a cool way to think about math, isn't it?
I'm just kind of gonna draw myself on a piece of paper for my mother, and she'll get like, "What are you trying to do?" What's not hard?
Dash, dot, dash, dash.
All right, did you all come up with an answer?
Yes.
Did you decide positive or negative?
Negative.
Negative? Negative in the back? Anybody else negative?
Negative.
Negative, yes? All right. I concur with the negative. So on the top, it was negative times negative times negative, which is
Negative.
negative. On the bottom was positive times positive. So positive, negative divided by positive is negative. So that means that the graph has to go
Down.
down.
Hopefully.
Beautiful.
Yeah, so that one looks a little bit nicer, right?
Well, that going up. I would have liked to do someone up.
I know, me too.
I did mine ugly and put it all in place. Why?
What?
I put it all in
Is this
place.
one?
Wait, it's up in the middle.
You see. You see.
All right, we have one more section of graph to make, yes?
Oh.
Over here. And we literally have nothing to go off of, do we?
So we could just do whatever we want.
No.
No, you can't.
You could do a loop loop in the middle of it.
Why is the loop-de-loop out? Because the loop-de-loop is not a function, and these are rational functions, all right? The main thing here is, what do we know cannot happen on this side? It cannot cross the x-axis. So either it's all above, all in the positives, or it's all in the negatives, because it cannot cross the x-axis because we do not have an x intercept. So we need to decide is it positive or negative, and then draw the graph either in the positive or the negative. So you may pick any of these values. You pick one as long as it is less than -3. So -4, -5, -6. You pick whatever number you want. Whatever number you want as long as it's on this side. This side over here.
-73.
You can use -73, yes.
Alright.
You may use -1 billion if you want.
I want it basically oddly specific. -7.
-5 works.
Negative.
That is true. If you really wanted to, you could pick this number. -pi, right? Because pi is 3.14, so that'd be -3.14. It would make it harder, but you could actually do it, couldn't you? Yeah. It would be right here, so it would tell us.
It's
I knew like
3.14159.
All right. We're getting distracted by pi. -5. -5. I picked -5.
It's positive.
It's positive? You got positive? Anybody else get positive?
That doesn't make me feel good.
I don't know what I got.
Do it again.
I take it back.
You're like, maybe it's not. You have a 50-50 shot and you have some math to make it through.
I got negative.
Negatives?
Yeah.
All right.
Yeah, I don't feel
You got negative?
Made it -4, Ava.
I did.
It doesn't matter.
I did -73.
I could have done -1 billion.
All right. So I'm going to go with -5. And you should have the same positive and negatives in the same spots as me, all right? So if I put in -5 at the very beginning, I'm going to have a negative, right? Times -5 plus 2 is still a negative. -5 minus 1 is still a negative. So no matter what number you picked, as long as it was over here, you should have negative times negative times negative on the top, which is a negative number. On the bottom, -4 times -5 is a
So confused.
positive. -5 plus 3 is a negative, and so I have a negative. So I agree with Ava.
Ah! I told y'all.
A negative divided by negative at the end is a
I'm so
positive number.
That's not
Y'all
Ava.
have me second here.
That's not Ava. That's Christine.
I agree with Ava.
No, that's Ava.
So you should, hey guys, you should, no matter what number you picked, have a negative on the top and a positive negative on the bottom. You should have the same signs in the same spots, no matter what number you picked.
I had the right signs.
I just Googled.
positive at the bottom.
I Googled. Yeah, what I Googled.
All right, let's finish this one. We're super close. So up here in the positive world, it has to go up along the vertical asymptote, right? From there, what is it going to do?
It has to.
Right.
Yeah. It couldn't go like all the way to the bottom.
Yeah, it's not going to go like this because that would make it a horizontal asymptote, right? So that's out.
They just curve.
So it's just going to curve and head back
Oh,
out. So it's going to curve. At some point, it curves and heads back out.
damn. You know, that's
Just make sure that it doesn't go flat, doesn't go horizontal, right? And make sure it does not cross the x-axis. Those are the two things that I would be looking for, that it doesn't cross the x-axis and it didn't go flat. All right. How are we feeling? Tired? You guys are more talkative today than any other day.
It's because of
Just because we're tired.
Oh, that's not normally how that works, though.
the first
But we're
day
Gen
were
Z,
also
so it's different.
tired.
All right, number 4 is the last one that we're going to do together. So I'm going to give you that head start, right? Head start. Y'all, I think it's
Where is that one at?
They did.
Next
They already
page.
know.
left and center.
There.
We're not a math class.
Guys, we're not scheduling.
We're this is an anxiety.
Actually, call them see if they want to come back. No, it's okay. But you need to schedule.
Oh,
They
what
can
if
come
we-
during my work.
Yeah, but that
What
means
if
you don't.
we didn't
If you don't have a
finish it
schedule,
when,
then
like,
you don't have to go to
started
school,
at
so
all?
don't do it.
Well, no, if they don't, you're
Yeah,
gonna, you better figure it out.
They're gonna
Or-
Meaning you'll get
Yeah.
And you should be factoring and finding the stuff.
Yeah, guys.
Hey, yeah, you forgot about my class. No. No.
Here, Michelle. You have it.
Yeah,
You
yeah.
have it. Take free count. So you want one or second one?
Hey, raise your hand if you're a freshman.
I think I am.
1, 2, 3, 4, 5, 6, 7. That's 7.
Yeah, she did, but would you, if you want, have you taken our? No.
We're taking it right now.
Have you taken?
Hey guys, focus. Last one, and then when we're done, you may talk all you want, and I will not interrupt you.
Can I see number 5?
Number 4, your fat. How does my factoring look? Is that okay? Did it on my head? Did I mess up some signs, or am I good?
No, you're
Good.
Oh.
You have +2, -3 on the bottom.
I know.
I have +3. Like +3 -2.
I have minus
Plus
three.
Yes.
-2.
All right. I had a feeling I messed those up. -2, +3. All right. Holes. Did you have any holes? No holes. Any vertical asymptotes?
Okay, no. It's, okay, I was like,
You're like,
you have a yellow form. So, come on, I'm going to this right, and I'll take the other, who else?
Another freshman. Who's going?
Come on, now, come on.
Brayden
And
will
then
go.
it's just one person comes in, y'all
Yep.
come back out.
All right, vertical asymptotes. What'd you find? -3, +2. X-intercepts. -2, -1. The top is they're both. It's +2 and +1.
Oh, yeah.
Yeah. All right. Y-intercept. 1/6 horizontal asymptote. -1/2. All right. So now we get to throw all this information on there. -3, +2, -1, -2, 1/6, and -1/2. It's a hot mess in the middle, yes?
Yeah.
Like, big hot mess in the middle. So let's do the two ends first, because we actually know enough to say where those go, yes? On this side, is it in the top or the bottom? Over here, top, bottom.
It has to be the bottom.
Has to be in the bottom. Why? Can't cross the x-axis. So it's going to run like this. And then on this side over here, top or bottom? Also bottom. Why? Can't cross the x-axis again, right? So it's stuck there in the bottom of both because it can't cross the x-axis. Now the middle is the hot mess. You ready for another?
Yep.
All right, another freshman. Who's next? Adam's next. All right, in the middle, there's a little bit that we know. We know these two are going to have to connect, right? And then these two are going to have to connect. So we know that this has to go this way, right? Between those 2 points. We know that little section right there. Yeah? So we're okay with that part? From here, we do know which way it has to go. It has to go up. Why does it have to go up? It can't cross the x-axis. So we know that section there. In terms of the rest of it, do we know here between these x-intercepts if it goes up or goes down between them? Does it curve across the top or does it go across the bottom? Do we know? We don't know. So what do we have to do? You have to pick a number in between. Negative 1.5?
Yeah.
All right, you all decide positive or negative. So we still have Ava and Sing, Michelle. All right. Enoch, do you have your scheduling stuff as well? You have your scheduling stuff? They might want you to go. Can't remember what. So you're checking negative 1.5 to decide if it goes up or down, right? So I get a negative over a positive at the end. So it would go down. So that means it connects under this direction. So it goes below to connect. And then you do have to check from there in terms of the vertical asymptote. Is it going to go up or is it going to go down? So you have to check one more number just to make sure we know if it goes up or down. So the best number there is what, negative 2.5? So check negative 2.5, decide if it goes up towards the vertical asymptote or down. All right, did you decide, does it go up or down? Down? Have it down? Anybody else down? We can check real fast. So it'd be a negative times a negative on the top, right? The bottom would be negative times positive. So I have negative times negative, which is positive on the top, and then negative times positive is positive. So it actually goes up. Yeah, it goes up. All right, so because I'll see you tomorrow, your assignment is just the next two, all right? The next two. And then when you all have